Hi, welcome to LCU14-303 Toolchain collaboration. My name is Arnold. I am the Linaro Toolchain Engineering Manager. Today's presentation will be on Toolchain collaboration. We've invited a number of member company representatives from Toolchain organizations to this meeting. We are recording this, so if you would like to speak or have a question, please let us know and we'll pass the mic to you. We're running a little short on time. We started a little late, so I want to get right into this. In the interest of getting through as much material as possible, we're going to try to be as succinct as possible. So when you present your slides, try to be thorough, and so we can pass on the mic to everyone so everyone has a chance to participate. Just a note, you can find the slide deck on Zarista as well as the Eatherpad link. So if you have comments or questions, you can add to the Eatherpad link as well. All right, so I'll start. We're going to sort of use a round robin approach. I have a few slides. I'm going to introduce the team, discuss the topic. We just discussed a little bit about how this is going to work. So we're going to go through introductions of each of the people here and what their development focus is for their organization. Talk about GNU Toolchain, roadmaps and specifics, LLVM roadmap and specifics, and then also system libraries, linkers, debuggers, and tools. So participating here today, we have representatives from Linaro, ARM, Qualcomm, Cavium, and ST. So you guys can read the slide here. This just discusses who we are, but the purpose of this collaboration for us is to improve collaboration in the ARM and AR64 ecosystem. We want to eliminate roadmap redundancy, I think is in everyone's best interest, and identify gaps in the ecosystem. So our focus from LCA 14 into 2015 is in four main areas: product validation, framework improvements, and these are hinging on our product offerings. So we're going to be improving our validation thoroughness. Hopefully into next year we'll be validating upwards of 33 configurations for every single backport we do. That puts us on the order of monthly performing around 500 to 700 toolchain builds per release in various configurations. We're also going to be focusing on toolchain performance this year, GCC and LLVM. Benchmark automation, it's a large member interest. We're going to be focusing on backports, release of binary toolchain benchmark automation and reporting. And finally, we have a number of product offering expansions for 2015. We currently offer 20 products. We've been asked to expand that to an additional 32 products, so that's a pretty significant increase. And this covers x86-64 hosted cross toolchains, ARS32 targeted toolchains, and ARMv7 and ARMv8 hosted toolchains. So I'll pass the mic to Matt Gretton-Dann, and he can go through ARM.
Hi, so I'm Matt Gretton-Dann. I am the engineering manager for production compilers at ARM, which means I have responsibility for the GNU Toolchain, LLVM-based toolchains, and also ARM compiler, which is ARM's commercial product toolchain. So what I want us to do here is basically, as Ryan's already said most of this, what ARM plans to work on, our current priorities. I want to say, come and talk to us, basically. If you want to work on, if you're working on similar areas, come and talk to us. If you think we've got our ideas wrong, come and tell us. And yeah, just work with us. The best place to work with us on all our public work is in the upstream community. On the GCC side, we're moving to having all our work on public side of stuff tracked in upstream Bugzilla as we work on it, so that you can come and feel free to come and comment on that and say, have you thought about this, you're going the wrong direction or whatever. We're not quite there on the LLVM side, but we're moving towards a similar thing for LLVM that we're working collaboration. So an overview of the goals for the year. With the ARM compiler team, there are actually about 50 engineers in ARM working on LLVM and GCC for CPU cores. You won't see all of them in the public because some of them are working on architecture stuff that's R&D that may never actually see the light of day in a CPU, right? I'm not going to talk about that today because that's all private, so that's not there. We want to support the community. We want to make sure that the community has best tools for ARM in LLVM and GCC. And we have performance. Obviously, we want the tools to work well and perform well. So yes, we're focusing this year mostly on Cortex A57 performance improvements. So we're focusing on a range of benchmarks. And we analyze those benchmarks both to make the code better ourselves, and also to make sure that the work that goes on upstream in the community doesn't cause regressions. And if we do find regressions, we work with the community to get them fixed.
We'll move to David here. So I just want to go through an introduction and not have your slides later going over LLVM.
Okay, I'm David Kipping, product manager at Qualcomm.
Kevin?
I'm Andrew Pensky. It's on. Okay, it is on. I'm Andrew Pensky, working at Cavium for the Toolchain manager.
You want to go through just what you guys are working on?
So basically, we support the GNU-based ThunderX Toolchain internally, and other Cavium products, including our Octeon. So, we have some either priorities sometimes. We've been making sure that, GCC performance area, we want to make sure that GCC performance areas are covered and not duplicated, because duplication is bad. What do I mean by duplication between different people? So different groups. So, Linaro not duplicating what we've been doing, and ARM not duplicating what we've been doing, and ST or whoever else, Qualcomm, just making sure that the work isn't duplicated. So we've implemented ILP32, including the kernel, glibc, and parts of GCC and binutils support. We also want to make sure that we've helped already in some of the performance areas in AR64. These are just examples, and we've done quite a few additional test cases results, test cases that that we've done that have caused by not internal performance problems, but internal patches that we've done, and then we might have actually removed those patches, but we've kept test cases around and submitted them upstream, just so we don't regress, wrong code or internal compiler errors. And there's been a lot of those in the recent months. Actually, that could be after. Yeah, because that's more the GCC stuff.
So we're going to cycle through. We'll cycle through the topics that I had listed in the front. So now we'll move into GNU Toolchain collaboration. So we'll start with my roadmap. I'm not going to go through this thoroughly, but this is a sort of a visualization of what we're working on. We have a lot of things in process and some interesting things out in the future. Significantly, the yellow blobs, those indicate things that we want to work on, that we will be proposing and working with member companies to thoroughly describe and verify. The really interesting ones, multi-arch compiler driver, that's a bit of a misnomer. We had some great conversations yesterday surrounding that topic and how we can solve some real problems. Also, sanitizer completeness on AR64 and ARM. Sanitizer's discussion yesterday showed some real holes in sanitizer implementation for AR64, so we're very interested in filling some of those holes. We also will continue with our Toolchain products and our releases and our community stewardship. That's always on our minds. And then just looking at some general performance in LTO and PGO, and then also sort of our normal performance improvement initiatives. So for GCC performance, I'll try to go through these quickly. Linaro Toolchain Working Group focuses on 4 areas of performance improvement. There are more areas. ARM focuses on other areas. We're trying not to overlap. So we focus on member-driven optimization. So when you guys have problems with your workloads and you identify that these are compiler issues, or if you suspect they're compiler issues, or sometimes they just make their way to me, we will turn those performance problems around and hopefully improve performance. We'll also work to own the performance of our toolchain products, so that's the second large bullet there. So what we do is we benchmark our own products, identify regressions, and then turn around performance improvements based upon investigations. We also do performance comparisons, so if we look at performance of a specific feature on another architecture, and we benchmark it with and without that feature, we want to see the same gains on AR64 and ARM. And then finally, we also look at feature exploitation, such as making the most of LTO and AR64, whole system profiling, and workload profiling. And those are two things that we really want to get into going forward. I won't really talk about the community involvement. That's just sort of a background task that we always work toward. And here on the product offering slide, like I said before, we're going to be potentially adding 32 new products and improving our validation of those products. You guys can read this slide as you want, but I'm not going to go through all of it. Benchmarking, I won't go through that either. This is just supporting one of those first objectives that I discussed. This is some information on what we're doing now and what we're going to be doing in the near future. And then I'll pass the mic to Matthew.
Cool. This is the ARM standard Smarty roadmap. Yes, basically, again, you can read this yourself. There's an awful lot of bullet points I don't plan to go through in the next couple of slides, reading them all. But basically, as I said, we focus the work, we split the work in the GNU community in thirds. A third we spend on quality, that's bug fixing, making sure tests pass. A third on features. Features include for us things like neon intrinsics or new libraries, or making sure that sanitizers work, although Linaro is doing that, but if ARM did sanitizers, that's where we would classify sanitizer as a feature. And we spend a third of the time on performance. Next. So here's a list of some of the stuff that we've managed to push up in the last 3 months or so. Basically, yes, we've done some. Oh, sorry, Kate.
No, on the Big Endian one, right now for ART64 support, given the timescales right now, what's left to do there?
So, Big Endian does work, but doesn't work. Ish. Big Endian works ish. The problem with Big Endian is mostly neon. Oh, sorry, the assembly on 64-bit. And yes, if you're at the GNU Cauldron, you'd have heard the IBM team talking about moving from Big Endian to Little Endian and all their problems with Little Endian auto-vectorization. ARM have the same problems going the other way, moving from what is a Little Endian architecture, really, to a by default to a Big Endian architecture with
so do you think you'll have gotten through most of them by the end of the year, or is it going to be happening more work still into 2015 on this stuff?
We've got a couple of people working on Big Endian. I would hope that they've got through the majority of the issues by the end of the year, but it's a compiler. So
sort of answer that. The sort of goal we have on that activity is to say we want to make sure there are no regressions, or at least we understand all the regressions compared to Little Endian. Some of that work is actually making it upstream, and we are trying to fix up the vectorizer where it's just silly. But again, this is a compiler, and as we said earlier, there are no guarantees that it will all get done.
Yeah, but the aim is to have something by end of year. Cool. So yes, so for those who aren't familiar with GCC development, stage 1 is the main development time, ends October 2014. The numbers, the GNU tool numbers, are just internal numbers, so if you want to come and talk about them. I'm not going to describe these. Our maintainers in-house have told me that now I'm a manager, I have no commit rights anymore. So if you so if you want, can write code, I can't commit it. So if you want to know what this is, go and talk to Romana, who is one of our GNU tech leads, and he can talk about this. So yes. Stage 3 is as GCC goes through towards release, it tightens up what you can do. So obviously, the closer you get to the release, the more important fixing bugs and regressions becomes. GCC has undergone a name-changing scheme, so it's going to be the main release is going to be GCC 5.1, I believe, but I'm still confused as to how exactly this is all working. But anyway, so yes, as we go to the first quarter of next year, that's the main thing. GDB and binutils, we don't have much planned. We will support the architectural roadmap as architecture comes out, and 225 has been released, but apart from that, we haven't got much planned for GDB and binutils. Maxim.
Other binutils features or problems left to fix for ARM or ARC64?
I don't. We aren't aware of any major ones.
There are problems in GDB. We have a current regression with the way in which FPCR is read.
Yeah.
I'm not. There are some bugs, but these are bugs, and that would be classified under maintenance. So.
Yeah.
Well, with the FPCR, it's Big Indian related too. So there's some Big Indian related bugs with GDB.
Yeah. Some parts of Toolchain seems to improve in Little Indian as well.
Right.
So we'll have to go look at that. But these are bugs. It's maintenance.
Yeah.
We don't have any specific features as such that we're going to work on.
Yeah. So this is not ARM is going to work on, but the Gold port for ARC64 is being in works, I believe.
So the gold port is in the works. There's a slide of things we don't have resourced somewhere on this, which is things we don't have resourced to do, but you're interested in. Gold comes under that. ILP32 comes under that. We don't have enough resource in-house, but we are keeping a watching brief on what's going on.
Right. David, did you have anything on GNU that you wanted to cover?
Sure. Even though I usually mention llvm, and a lot of people at Qualcomm might mention llvm, practically at the moment, GNU is the most important toolchain, and we're very interested in results on that. In terms of a Linaro context, though, it's not very significant for us in terms of Linaro's work, because unless Google picks it up in Android, it doesn't really give us much benefit in terms of volume production. We do use internally for some projects Linaro Toolchain. We also have a Dragon board that uses the Linaro Toolchain, but those really don't have significant impact on shipping devices. So unless it's delivered upstream for the next release, or it's delivered and rebased and picked up by Google, it doesn't have significant volume impact.
Oops.
Yeah, sorry.
Did I miss? No, I skipped you. Yeah, yours is up at the
Yeah,
there we
no,
go.
it's also like,
All right.
yeah, sorry about the order. That was my fault. I try to order it right, but so what we're going to be what Capim's going to be focusing on is finishing up streaming ILP32. So glibc patches are almost done. GDB is very minor. It's more about not rejecting ILP32 in some places, because the way BFD right now is done is actually causes GDB to fail. So we'll be fixing up that. I have a patch, I just need to forward port it. So the other stuff that we're going to be working on, base ThunderX support, not included schedule model to begin with because of many different reasons. And then we're also, well, we pretty much don't have much for GCC 5. But GCC 6 will have quite a few stuff, like conditional move improvements that we've had in-house for a while now with our Octeon products and our ThunderX products. And we're going to be, once the conditional compares go upstream, which I think I've heard that there's a big movement to push that, we have a couple of extra improvements on top of the patch right now. So we're also going to look into supporting large system extensions, which actually, it's not quite announced, but there was a patch on binutils, so I can talk about it. So Joel posted an infrastructure patch that was rejected, and I think I need to talk to Marcus to see how that might be done. And also hardware cap support in the kernel and in glibc. One big question, I don't know if this is the right form for it, is what path for glibc to look into?
Sorry, what?
For the hardware cap. So in PowerPC, for an example, they have Altivec as the secondary for the hardware cap. So you have user lib, Altivec, or user lib. What would be the best directory that we could use?
I'm going to say I think we need to take that discussion offline, I'm afraid.
It's okay.
Marcus needs to be involved in that discussion, and he's not here.
Okay. Okay. Right. I figured as much. That's why I said I don't think this is the right form, but
we can discuss it. That's fine.
okay. And then we also have some small tweaks to the cost model that we need for ThunderX support. One example is loop prefetch. Well, actually, we're going to be looking also into loop prefetches, arrays. Something for our processor, not necessarily for others. So it might not be turned on, but we need a cost model part added in. So that's something that we're looking into.
So on the AH32 side, the prefetch loop arrays is turned on only for A9 and I think A12. But we do have, as long as you put it in the generic, in the cost table structures, I think it should be fine. Yeah, which is sensible.
All right, I'll move into LLVM roadmap here. So if we can get through all the base slides, then we can open it up just for general discussion. So Linaro's LLVM roadmap. This is an interesting slide. So everything you see above the line is what we're currently covering. This is all done by one person, and there's more. I was informed yesterday that I was missing something else that you do, Renato. There's not a lot of room for other interests, and I know many of you have interest in Linaro working on what you see below the line. There's a lot of interest in performance improvements, sanitizers, well, the unified compiler driver, we discussed that earlier, and then LLVM integration on Android for AR64. So we've been talking with all of the members about how we express your interest and how we'll envision your interest as far as what we're working on. So those discussions will continue.
So at Qualcomm, LLVM is very important, and we really want to make it the compiler of choice for all processor cores. So today, actually, for the DSP and for the GPU, LLVM-based compiler is default. And we would like to see, for the CPU, to actually have that same level of acceptance by the end of next year. And for us, that kind of means Android building with LLVM, and also having LLVM as competitive performance. We also want to, realize the full benefits that LLVM and the LLVM family of products really brings, not only to the other cores, but also to the CPU. And that's really the sanitizers. But there's also some features in the ecosystem that help improve code quality. I think this is a significant weakness, though, in the ARM ecosystem. The people at Google that are creating the sanitizers, they really only care about x86 today. It's on their server deployments, and others tend to port it at a slow speed to the ARM ecosystem. The Android team internally are using the sanitizers, but on x86. Thread sanitizer, which I think is the biggest weakness, is not running on ARM, and at the moment I know of no one working on that. So I think this is a specific area of weakness in terms of LLVM and GCC for the ARM ecosystem. Oh, okay. So we've been working quite a bit on ARM. We've worked with ARM, and this goes back more than a year. On the initial AR64 backend, there was Apple very late stage, latter part, a number of months ago, said they released their backend, created a discussion in the community, and we worked with the community to complete the merge and now make it available. Areas that we focused on was also, A53 machine description, A57 machine description, which is in the process of coming up. We also contributed on LLD. We're very interested in ultimately migrating to LLD as the basis of the linker. It opens up some interesting, once you can influence the linker, there are some very interesting things you can do both for code quality and also for link time optimization. And then we did work on commercializing ASAN on our platform, so most of that was bug fixes. And then going forward, we'll continue working with the community, with ARM, on specific performance, make sure that we are not duplicating effort. One thing that we're very interested in is the greedy inliner. That's somewhat controversial, and at the dev meeting there will be a session on it, a BOF, to decide on the upstreaming of that. Another area we're focusing on is, along with the rest of the llvm community, profile guided optimizations, feedback, which is looking very promising. And then we will incrementally use sanitizers, bringing them on in our environment, addressing bugs and performance issues.
Incremental use of sanitizers, meaning that as more sanitizers like TSAN are becoming available on ARC32 and ARC64, you are going to start to use them? Or creating more sanitizers?
We haven't caught up to the very good sanitizers that are there. So we have undefined sanitizer, undefined behavior. We also have ASAN. Probably in the near future, we'll be looking at MSAN and LSAN. So it's really bringing them into our environment, making sure that they really work on a small device in the configurations that we have. And if there are missing ports, then maybe helping out. TSAN, though, while we're very interested in, I don't think we have the resources in the next 6 months to address that.
That was just basically what I discussed in the previous slide. Go ahead.
Oh, it is me.
It is you.
Yes, it's a smarty again. So yes, again, so this is the roadmap, what's happened in 2014 going on to 2015. Again, tuning for microarchitectures, performance. As David said, there's the back-end merges, which has been very successful, I believe, and just it's best of both worlds going forward there. So that's that. Next. So I have to say, I don't have someone from my LLVM team here who could be the magic engineering person for LLVM to talk about, but I'll let Ryan sort out his slides issues.
My mouse is acting on its own. Sorry.
But yes, basically this list of things we're looking at, so that's what's been done. So back-end merge, performance improvements, and it's playing.
Oh, I have a mouse in my bag. That explains it. There we go.
There we go. And yes, stuff's been done. Performance stuff and making code better and initial support for Big-Endian. Next. And again, I'm not going to go through this. I can explain it to you if you want, but it's fairly technical detail stuff. But yes, there's stuff going on for performance improvements and general improvement to the compiler and the back end for ARM and ARC64. Next. And that, yep. And improvement of stuff. One thing to note, of course, is that ARM, Linaro is very much focused on the A profile. ARM, of course, cares about all its CPUs, so there's R&M profile tools, and the commercial toolchain ARM compiler from version 6 is based on llvm, and so we're doing a lot of work there just to make sure that the whole ecosystem is supported in llvm. So yes, a lot of the work we've done is focused on A profile, but also benefits M and R profile, and we have people who are also focused on M profile performance. Renato.
Do you have a time frame for the billboards, the Juno billboards?
I don't have a time frame off the top of my head,
Right.
but I can get you a time frame for.
Excellent.
I can see what.
Because yeah, so some of them are already done. So the benchmark is already running for v7, and it's, if you guys would like, I could have Juno billboards at Linaro. I just need them, the boxes, and I could do that. I know you guys are trying to do this. I'm not sure which way is simpler for you. So whichever, yeah. I'm ready to do.
Yeah, let me go back and talk to Christoph and people, and we'll see.
Okay.
Oh, I'm happy to keep going if.
Well, if you have more, you can.
I've said what I want to say on LLVM.
Okay. We'll move into just the last segment. Let me check our time here. Okay. All right. So what's next for system libraries and dev tools? We're looking at a number of things going forward. We'll start with GDB first. In GDB, we're looking at finishing GDB on Android for ARM v8 support. The big chunk there is catch points. We want to be able to cross-debug Android from your x86 desktop. We're going to look at ARC32 and 64 completeness as far as test suite parity. We want to have some reasonable expectation that the test suites are at parity. Also looking into ARC32 mixed mode debugging. So as far as system libraries, we're continuing to look at potential improvements in malloc. Those are ongoing. The hinge point is, of course, the malloc benchmarking. Can we prove performance improvements? So we're going to be starting from there and then continuing into a few different investigations as far as improving malloc. We'll continue to work on string mem function optimizations. We're largely focusing on ARM v7 or ARM and ARC32 at the moment. We know ARM themselves do quite a bit of the ARC64. A lot of this improvement is driven by members and member interest in this particular area. And we'll just continue with our GDB and glibc source package releases, as well as binutils, where we're backporting optimizations that are coming off of glibc, binutils, GDB trunk.
That's cool. So we're also doing string routine improvements, mostly focused on ARC64. So that's when we say string routines, we include mem routines in that. Maintenance activities and working with the communities to get 221 released. As I said before, here's some list of things that ARM's not currently doing, but we're interested in seeing done. Linkers, LLD, Gold, libc++, the sanitizers, which has come up many times already today, but, and ILP32. That's basically our areas where, yeah, we're still limited resource, and those are things we don't necessarily have the resource to do at the moment.
So are you interested in libc++?
Yes.
Right, because that's my next task on the roadmap, which means if you can give me the things you're interested in and what you're trying to do with it, it will be good, so that I can actually make this into a requirement and work that way.
Yeah, cool. I'll talk to you later.
Yes, again.
Well, I have one thing. Sure. So we're also going to be looking into string routines, but just from a ThunderX point of view instead of a A53, A57 point of view. So we'll be testing your guys' stuff out and making sure it runs as fast, and then maybe using ifuncs in some cases. And I need to figure out how to have the architecture passed from the kernel down to glibc soon.
Once again, talk to Marcus. You'll want to know how that's...
Well, it actually will be between Marcus and probably Catalin or Will. Will Deacon, not you. Will.
All right, so we have, I think, about 8 minutes left. So I'd just like to use this time to discuss whether anyone has identified any gaps or knows of any gaps in the collaborative roadmap.
Where is that? Is there anyone from Google here? From Google? No.
Kind of.
Doing a bring up LLDB on Linux. That counts. So not specific. I'm doing a bring up. My team is doing a bring up of LLDB on Linux as a stepping stone to getting it into.
For the recording, we're doing a bring up of LLDB on Linux as a stepping stone to a bring up on Android. And if everything works out, hopefully focusing on that as the main debugger for Android. So I noticed that LLDB is very absent from the slides, and I'm curious to know what people's thoughts are.
I think only Qualcomm might be interested because I think ARM has their own debugger, and the rest use GDB except for Qualcomm maybe.
So replace LLVM with LLVM family, right? So LLDB is part of our strategy. Currently is the debugger for the GPU and the DSP. We're very interested in it working on CPU with, particularly with Android.
We asked the question in Macau last time. Does anybody have any interest in LLDB? And no one did. That maybe it's the wrong people. Well, the right people weren't there, I don't know.
And the thing is, like, debugger is less important than the linker. If you want like a stereo. If you want a full toolchain, the first step, the step now is libraries and runtime and compiler libraries and everything. And then the next step is the linker, so then you can at least compile the thing with LLVM. And then LLDB and other stuff. So it's just like, it's one thing after the other, but I don't see why we wouldn't want to use LLDB.
So moving away from LLDB, unless you have further comments. So there's a lot of interest in the sanitizers, and we have an interest in executing on some improvements there. What do you all feel are the priorities in that area?
TSAN?
Yeah, though I think that's going to be tough work. Probably I found out yesterday that LSAN isn't working, so I think that would be low-hanging fruit.
I hear some members are interested in TSAN or multi-threading, because now we're going multi-core. You know, we really need to trim out these things. So
yeah, TSAN and LSAN is definitely important.
Do you have a relative priority?
No. But so ASAN is the highest. But I have another question. Valgrind support. Is you guys anybody working on Valgrind support or?
I think it's just been announced last week.
Well, I mean, keeping it, you know, is Linaro looking forward to actually supporting it as part of their distro or part of their collection of tools?
We haven't had member interest. We haven't had explicit member interest yet. We are gathering sort of background and surrounding information on tooling in general, and in fact, I think Kate is working on that.
If you're interested, so if you're interested in any tools that are not normally mentioned in the sessions, so outside of compilers, linkers, debuggers, tools like Valgrind, Perf, O-Profile, G-Prof, yeah, so tell us, tell Kate, tell Ryan, tell me.
Yeah. There's a bunch of initiatives with various trace formats and performance monitors and hooking these things into various tooling. And so if there are things that people think we should be looking at, please just let us know.
Or maybe Eclipse integration for our compilers.
So right now the thinking for Android performance analysis is that we're going to start with something perf-based. And so we'd like to make sure that perf is working really well for all the supported architectures.
Yeah, perf, O-Profile is lower because now it's built on top of perf. What other? Maybe, as I mentioned before, a userland library which is built on top of perf that you could read the performance counters. And I know there's an initiative in the LNG to start working on that. I don't know where that's going to go, but you know, and there's a demo I think tomorrow about it. So if anybody's interested,
It might be Friday. Or is it tomorrow?
No, the LNG demos are tomorrow.
Okay.
So there's a userland library they're just starting to work on, but it's right now ODP specific, but it can be generalized if there's more interest than just ODP related.
Okay. Well, we are out of time, so just a quick recap on how to continue this discussion. So if you are a member company and you have specific requests of Linaro, please have your representatives talk to Kate or me, and we will start the discussions with the other members in the ecosystem. If it's upstream related, please use the upstream resources first so that the discussions happen in the open and so that everyone is happy with how those discussions progress, because everything we're interested in will likely have, will require likely input from the rest of the upstream community. So let's have the discussions there. All right, well, thank you very much.